Hi guys, welcome back. We're going to talk about 10.5, which is experimental probability. So when we think about the word experiment, remember that means we're doing something and seeing what the outcome is, what will happen. So the first thing we need to do is think about what are all the possible outcomes for an experiment. So if I'm flipping a coin, what are all the possible outcomes? Well, I could have a head or I could have a tail, which we'll shorten to H and T. Now when we write all the outcomes, we write them in these special brackets or fancy brackets. I'm going to write a better one here. And we label it with an S, and S stands for sample space, and sample space just means all the possible outcomes. So we'll see that frequently when we're writing events. So when we're flipping two coins, the first option I could have is the first one could be a head and the second one a head. The first one could be a head and the second one a tail. The first one could be a tail and the second one a head. And then the last one could be two tails, Okay, so there's four possible outcomes if I'm flipping two coins at the same time. If we're spinning a spinner with the primary colors, all of our possible outcomes would be blue, yellow, and red, because those three colors can make the other colors. Next, we want to know what the likelihood of an event could be. Is it impossible, like it's never going to happen? Unlikely, like probably won't? Likely, it probably will? Certain, 100% it will? Or as likely as not, which would mean equally as likely. So, is the event 31 days in August going to happen? That is certain. We know because that's how we've made our calendar to be, and that's going to happen every time. Josh correctly guesses a number between 1 and 1,000. It's not impossible that he would get it, but it's probably unlikely. That is a lot of numbers for him to choose the correct one that you chose. So we're going to say unlikely. A coin lands on heads. This would be as likely as not. Because it could land on heads, it could land on tails. They have the same chance of occurring. So we're definitely not going to say, well, it's likely, because it could just as likely not happen. Jesse rolls a 10 on a standard number cube or a die. Well, there's no 10 on a die, so this would be impossible. Okay. Next, we're going to actually practice finding the probability of something. So, finding experimental probability, an experiment consists of spinning a spinner, and the results are recorded below. So frequency is just how many times this occurred. So we landed on red 7 times, blue 8 times, green 5 times. So right here where we have this P and then in parentheses, the P stands for probability and the parentheses stand for of. So this is probability of getting blue. Okay? So remember probability, the total goes on the bottom. So we're going to add all of these up. So 7 plus 8 is 15 plus 5 is 20. So we have a total of 20 total items, 20 total spins. And on top would be how many blue we have. Well, we have 8 blue. And as good mathematicians, we're always going to simplify top and bottom, so that would be 2/5. So we have a 2/5 chance of landing on blue based on the experiment. Now, probability of not green. Okay, so probability of not green, so it would mean getting anything but green. So we still have 20 total options, and not getting green would be 8 plus 7, which is 15. And again, we're going to reduce to 3/4. So we have a 3/4 chance of not getting green. So there's a good chance we won't get green. Next one, a manufacturer inspects 800 light bulbs and finds that 796 of them have no defects, so they're golden. So what's the probability of no defects? Well, we know there's 800 total light bulbs. Out of there are 796 without any issues. So if we do 796 and reduce that, typing in my calculator, so that would be 398 over 400. We can reduce that again. I'm just dividing it by 2 out of 200. So we have 199 out of 200 chance of getting a good light bulb. So if they send me 2,400 light bulbs to a store, predict how many light bulbs will be defective. So what we're going to do is we would multiply the probability by the total number of bulbs. Now, I am going to use the original fraction because I can see that I would be able to reduce some things, but you could use, whoops, that is not right. But we still could use the 199 over 200, and I'll use that next to show you. So if we didn't reduce, and this is over 1 and we're multiplying, I would cross reduce. So I would say 800 goes into 2400 3 times. And 796 times 3 would be 2,388. And they want to know how many bulbs will be defective. So we do really want to use this fraction because it's talking about the whole package. Okay, so we should get the same answer either way just because it's reduced, but it's better in case you accidentally did something wrong. So we're going to do 2400 minus 2388. So 2400 minus 2388 would mean that there are 12 defective light bulbs. Okay. Now again, if you did 2400 times 199 over 200, 200 goes into 2400 12 times. 12 times 199 is going to give me 2388. 2400 minus 2388 is 12. So it doesn't matter which fraction you use if you reduced. I just might use this original one just in case I reduced wrong so I don't get the second question wrong, even though I